I'm Abby. I'm a third-year biomechanical engineering student. So the way that Merlin is currently structured is that we have three main technical teams. We have one team focused on brain-computer interface application development, which is currently working on a video game. We have one team which is focused on software development, which is currently working on back-end code of two separate APIs. One is called BLE2LSL and one is called WizardHat. And we have a hardware team which is currently focused on the design of a PCB board. One of the main goals of Merlin Neurotechnology is to increase the accessibility of Neurotech to anyone that is interested in the subject. By doing this, we produce a lot of open source code that allows users to overcome the back-end obstacles of getting involved of data collection and data transformation. The software development team mainly focuses on the development of this open source back-end code and is actually led by Sam White, who will tell you a little bit more in depth about the projects that we've been doing and about the team members that we have assembled.
My name is Sam. I'm a second-year engineering physics materials student here at Queen's University. I decided to join Merlin Neurotech because my program doesn't have a lot of software and coding skills involved, and I wanted to branch out and become a well-rounded person in a technical field. So after being offered the position for the chair of the software development team, we went around to hire the members for the team. We ended up with a very diverse skill set.
Hi, my name is Cameron, and I'm currently in second year computer science.
Hey, I'm Mohammed. I'm in biomedical computing. I'm in first year.
Hi, my name is Mukund. I'm a third year student currently at Queen's in the Apple Math program, the robotics option.
Looking at the code that was previously submitted last year, we decided to split up WizardHat, that was one API in itself, into two. We split this up into BLE2LSL and WizardHat because after looking through it, we saw that there was one component of the code that was basically for streaming and only for streaming to be sent as a stream to WizardHat, which then processed all the data and plotted it using bokeh. By splitting them apart, people and programmers can either use BLE2LSL just if they want a platform to help them stream from uses and different devices, or we can have people that just use WizardHat that have their own streaming API and just need help with the data manipulation process. Throughout the year, we worked on a multitude of projects. In a master list, our team would then work on a task that was on the master list and then bring any problems that they had to the meeting. And it was like a group work peer tutor session with the master students and the software development team. This was really helpful because any issues that we ran into that we couldn't quite fix by looking things up on the internet, we had insight brought to us from the master student that worked on the project in previous years. Projects that we worked on that were actually a great success was one of the issues coming into developing both APIs was that you have to create a live stream to then perform the WizardHat transformations on your data. So through some trial and error and thinking, we actually created a method called Dummy, which then takes old streamed data files, CSV or JSON files, and it sends in streams, just like a Muse would, to WizardHat, and then you can do your transforms all together. So basically it creates a virtual stream that WizardHat then collects and does all the transforms and plots it for you in your program. A second project that we worked on throughout the year that was a success as well is, figuring out what was happening and all this code was a huge issue. And so by logging and tagging everything that was happening so we know where the code's going was a huge plus for us. So we've spent a lot of time, just upping the documentation and logging on the code just to make the process a lot easier for years to come when trying to get new members associated and familiar with all these, APIs that we have developed so far. Some tasks that we worked on and didn't complete or failed at was trying to connect two muses from one stream on BLE2LSL. This failed because we found out that after multitudes of trial and error in Jupyter Notebook and just trying to get that one piece of code to work to actually just stream information, the information was then getting jumbled together and we had no way to organize it because it was getting jumbled randomly. Near the end of this year, when getting more familiar with the program, we noticed that when trying to develop the program and test it, when bokeh was plotting all of the threads were running, we saw that Control-C in the terminal wasn't quite working. It did stop the program and the plotting, but it didn't create a new line in terminal, which means one of our threads which we are yet to find, keeps running within our code. Throughout the summer and into next year, I think a huge thing to work on for both APIs is making them a lot more user-friendly. From my experience starting up using both programs, it was a huge learning curve. Even if I did want to just use them as a programmer to help me bridge the gap between having a Muse and controlling things and making a BCI project myself, I think that with further documentation, we'll then up the usability of our two programs. Now we're going to do a demo of a script that you can run right off the bat after you've downloaded and pulled BLE2LSL and WizardHat off of the GitHub and onto your own computer. So taking a closer look before we actually run it, we have our Muse headband here, and that's what we're going to be using to stream some EEG data signals. So first off in the script, we import BLE2LSL, which is our streaming outlet API, and then from BLE2LSL, we do have a package called devices. Devices has a list of different devices, for example, the Muse, and basically depending on the device you're using, how it sends information changes, and the code preemptively accounts for that based on the device that you pass to BLE.devices. So here we're importing the Muse 2016 because that's the one we have, and Ganglion, which is this Bluetooth adapter that we have right here. And then from WizardHat, which is the transferring of data and manipulation package, we import acquire and plot. So we're going to acquire the data, and then we're going to plot the data on a local host. Acquire takes in a receiver, which is a streamer, and then that is going to be used to then plot the data. So then we import PyLSL as LSL. So we set our device equal to Muse 2016, which is what we have here, and we've imported it from BLE to LSL.devices. And then we want to plot stream. We're plotting the EEG signals from the Muse. And then, so if the name, so this is in our init file, equals main, which it already is, it's going to run these lines. So we're going to make a streamer object, and it's BLE2LSL.streamer, so we're making a streamer in BLE2LSL, and we're passing it the device. So now the stream knows how to properly order itself. So we're plotting the EEG data signals from the Muse headset, which, so in that 6x12 matrix, EEG is only a certain portion of that, and the program knows based off of how it sends its data, because it is a device that we've preemptively wrote a file for. It knows based off the name which files and data to then plot. So we're going to turn the Muse on, and so we've entered a virtual environment already preemptively, and so basically we're just going to type Python and then example plot.py, and so if you see here, it's blinking, so it's being ready to pair, and when it's a solid color, it's going to be connected to the computer, and then that's how you know the code is past that stage and will start streaming to the receiver. So it's a solid color right now, so we know soon, here we go, a local host opens up, and here we go plotting all of our data. So you see we have time on the x-axis, and we have a plot here, and as I concentrate and do different things, you can see it spike and whatnot. And this is what we have for our example plot.py. So as mentioned before, one of the new projects that we work on this year was streaming old data to our computer to then talk to WizardHat and get transformed, so you don't have to do live streams all the time. You can do off-stream data manipulation and treat them as streams and receivers and such. So through that, we updated in BLE2LSL where dummy was, that dummy class. We then added a replay function, and basically very similarly to the example plot.py code that I showed before, where you have your receiver and in your devices sort of how it's structured to be sent into WizardHat. What replay does is it takes in the same BLE2LSL device and a folder where the data is going to be stored. And basically what this does is then it prompts you to pick a file which you want to stream, and then that file, CSV or JSON, will then be streamed through WizardHat, through the acquire function again, and a receiver to then be plotted. And it will be in the same format as actually streaming a Muse 2016 real time. And if you were to change the device here, it would then change the format of the fake stream data to the receiver based on which device file you send it. And those are all preemptively coded in the device file. We have multiple lists of devices that you can choose from.